All right, so now we are on 5.3, Galileo and gravity. So we have this equation, d equals 16 times t squared. We already talked about this a little bit in the previous video. So it's asking us, how far does it fall? How far does it fall in 0.5 seconds? So what we need to do is we need to use the equation that was given to us, 16 times 0.5 squared. So I'm going to get my calculator and I type in this exactly as I see it. 16 times, I use my parentheses always when I'm squaring something. And then squared, so parentheses around the 0.5, and then square it. And what do I end up with? I end up with 4. So how far does it fall in 0.5 seconds? The answer is 4, but it's actually not 4. Remember, this is in feet, so you always have to include the units. So how far does it fall in 0.5 seconds? Well, it falls 4 feet. All right, so next it says to find out where the object is after a few seconds after it was dropped, Elena and Diego created different tables. So Elena's table is on the left and Diego's table is on the right. So my first question says, how are the two tables alike? How are they different? Well, they're alike because they both have time in seconds. So I see that, time in seconds. And they also have distance in feet. So basically they have the same units. And if you didn't know, FT is the abbreviation of feet. So they also have the same time interval, so from 0 to 4. And they're also describing the same object that's falling. It's the same thing that's falling in both of them. But what's different is that this is the distance fallen in feet. This is the distance fallen from the ground. Or excuse me, distance from the ground, not distance fallen. So this is the distance fallen for Elena, and Diego is actually looking at the distance from the ground. So two totally different things. So if I have a building, Elena's looking at it like this. The distance that it's fallen, whereas in my mind, Diego's looking at it more like this, where it's like he's comparing it to the ground. She's comparing it to the height of the building that we're dropping it from, which was, I think, 576 feet. So she's kind of more of like looking at it from the 576 feet perspective, whereas he's kind of looking at it as, well, how close is it to the ground at this point? So I should actually erase this because they're both really looking at it going downward, but he's looking at it more in the sense of how close is it to the ground at this point, and she's looking at it as how far away is it from where we started at. So that's why when you look at these, the first numbers, his is going down and hers are going up because she's looking at it from a different perspective than he is. And we can see that even further because at 0 seconds, she's counting it as 0. Whereas for him at 0 second, he's counting it as 576. And again, that's because he's comparing it to the ground. So even though I drew these arrows the same, they're kind of looking at it in an opposite way. All right, so let's actually fill in the table. It says, complete Elena and Diego's table. Be prepared to explain your reasoning. So how am I going to do this? Well, if we plug in 0, we get 0. 16 times 0 is 0. If we plug in 1, 1 squared is 1. Do we get 16? Yeah. So let's see if I plug in 2 into this. will I get 64? Yes, I do. So what I'm thinking is I just need to use the same equation that I was given up here to determine what's going to be at 3 seconds and what's it's going to be at 4 seconds. And what that is, at 3 seconds is 144. At 4 seconds is 256. And then it's interesting. They just give us a variable here. Well, I can still solve this. I could just plug my variable in. So 16 times t squared is just 16t squared. So for any time t, it will be 16 times t squared, or 16t squared. So that's a lane S chart, a table. Well, what's going on with Diego's? So over here with Diego, I need to figure out what's going on. So first I'm going to look between 576 and 560. And I see that there is a deficit of 16. It's going down 16. Then I'm going to look between 560 and 512, and I notice it's going down 48. Well, that's similar to what's happening over here, but opposite. This is going up 16. And then between 16 and 64, it's going up 48. So I feel like I know what's going to happen next. I could use this again and see, well, between 144 and 64, how much did it change? And it changed by 80. So I could predict over here that this is going to go down another 80. I could predict that. And I would get 432. The other thing that I'm noticing is if this is 576 from the beginning, and then it's going down by these increments, which match these over here, I'm still using the equation. Whether we realize it or not, we're still using that equation. But now I'm doing 576 minus 16t squared. So whatever you get for 16t squared, if you plug in 0 or 1 or 2 or 3 or 4 or anything, if you subtract that from 576, it will tell you the distance from the ground. So I could use that, or I could continue to use this logic over here if I didn't realize that I could use some type of equation. And I would see this is going up 112, which means from here to here it's going to go down 112. So that would give me 320. And I kind of jumped the gun a little bit, but that's because I saw the pattern. When it's asking us to plug in t, well, what's happening? 576 minus 16t squared. So I encourage you to go back, pause through the video, and just try and understand what it is that I'm saying with these differences on the side. How is this going down? Why is it going down by these numbers? Why is this going up? Why is it going up by these numbers? How do the two tables relate to each other? We know that they're alike and that they're different, but why? How am I getting this here for t, and how am I getting this here for t? Okay, so take a look at those things.